So, what's up, fellow engineers? And yeah, I already did some videos of my mountain bike data acquisition system called TRAZER, which is right here. And they were basically test runs, but no explanation of it, of what it does. And today I'd like to show you the whole system a bit more detailed. And yeah, maybe you can take away something of it. We'll see. So I will show you the whole system once I get a spot where I can find a spot, sorry, where I can put my bike and show it to you. Also, in case you didn't notice, English is not my native language, so please forgive me any mistakes. But yeah, talk to you soon. So, TRAZER basically consists of three parts. The brain, which is like here, which is the main processor and system. Then we have the front sensor for the fork, and on the other side is the rear sensor for the rear wheel travel. You can basically mount each sensor on whatever side you want, doesn't really matter. The brain here is based on ESP32S3 microcontroller that logs the data and also provides a web server, so you have an interface to communicate with TRAZER, and yeah, you can do the whole analysis of the data right on your phone, connected to the main unit here. The main unit also has a GPS module inside, which is used to calculate the speed, average speed, maximum speed you rode, and also logs the GPS points at 1 Hertz. So you have a GPS track which you can later use to trim your session based on the GPS points. The whole system currently logs at 800 Hertz, which is a bit too much, I think. It's a bit overkill, so I will reduce it to 500 Hertz so the data files get a bit smaller. Yeah. The whole system is controlled by this button here. That also shows the state. Right now, when you turn it on, it's fading. That means it is looking for a GPS lock, and as soon as it gets solid, that means it has a GPS lock. Right now it has one, and when you press the button, it starts like doing triple blinks. That means the system is currently logging, and when you press it again, it stops, and it's basically solid again. Yeah, that's how you record a session. Going to the front. The front sensor is a spectra symbol magnetopod that is basically a normal linear potentiometer, but it is actuated by a magnet, which is down here in this plastic part on the outside, and the magnet is sliding in the middle of the magnetopod, and that's how the resistance changes. In this version it also has ADC up here, which offers 12-bit resolution. I put it here because I read somewhere that the data lines between the sensor and the ADC should be short, but that turned out to be not quite true, I think. So in the next version the ADC will also sit in the main unit, so that piece here gets a bit smaller and you can mount it easier. Also, I will try a normal linear potentiometer next, so the whole system can become a bit smaller, a bit prettier maybe also. But yeah, I will then check which sensor worked better and decide from there how to continue. The mounts are printed, 3D printed in TPU 95A, I think, which is quite stiff, but still flexible if you print it like thin. So you can do one mount and fit it around different forks. That works actually pretty great. The same goes for the top mount, which is connected to the fork by some 3M tape and also a zip tie just to secure the connection between the two parts. The rear sensor is a bit different than what other people seem to do. It's not a linear potentiometer, it's a rotary encoder, an AS5600 sensor is right inside here, and I chose to do a link arm system here that makes mounting the rear sensor more universal and easier to switch between bikes. And also, as you can see, I ride a Santa Cruz with a VPP system, and mounting a shock sensor down here in the shock tunnel is actually pretty tricky, and I wasn't a fan of that idea to have a really bad hassle down here to mount the sensor. So that's why I chose to go this route, which actually works pretty great. It also makes the whole handling of the system a bit easier, as TRAZER measures wheel travel in the vertical space directly, as well for the rear as well as for the fork. And when I measure wheel travel directly, I don't need a leverage curve, because right now the whole system does not care about what the shock is doing, only what the rear wheel does, and the front wheel of course. So that makes it a bit easier, because not every manufacturer provides a leverage curve, and the SYN software and the linkage software, you can basically throw your bike up in there and get the leverage curve from that. But I wasn't a fan of the idea that every user of this system also needs the linkage software to create leverage curves. So I'm a pretty big fan of that idea with the linkage driven or link arm driven rear sensor, and it seems to work pretty great too. So the interface looks like this. You can connect to TRAZER with an access point that the brain provides, and then you have different options here, like to the calibration, also record a session, but you don't really need to use that. I maybe remove that because you have the button to record a session. Also live view to show the current positions of the sensors. Some settings where you can set the time and some other stuff, and also the main part, like the analyze section here. You can open that. It's not the fastest system, as the processor has to do multiple stuff at once, but it works. In the analysis part you have the different sections like front, rear, balance, guidance, and compare AB, which calibration currently is loaded, and now you have two different options. You can select a session directly from the device, or you can select a session you downloaded earlier, which we will do right now. That one works a bit faster because when you select a session from the device, it first has to download the session to your phone, and only then you can analyze it. So the external one works quite fast. Once the session is analyzed, you have the summary of the data here, like dynamic sag, front rear, total compression strokes, rebound strokes, max travel, yeah, and the GPS data I talked about. You also have a position over time graph here, where you can zoom. On the phone everything is quite small, but you can also open that web address on your computer, and then the different parts get a bit bigger. The GPS track is shown here without the map, because right now we don't have an internet connection, so TRAZER cannot load the map files from the internet. That's why. You can also trim the selection here and reanalyze only that selection then. For the front, we have also a summary of speeds and travel, different graphs like axle position, front deep travel, compression length, rebound length, and an impact recovery right here. Wow, you can totally not see that. Well, I hope you can. And the same goes for the rear. And also, yeah, just show you. Everything orange is for the rear and everything blue is front. Then the balance part shows the data compared to each other, like front, rear for everything. Then you have the position, distribution, compressions, balance, combined, front, rear, velocity distribution, yeah, and the classic scatter plot. Same for the rebound. Then I created a speed ratio comparison by travel zone. Yeah, and the difference for start position. The guidance part shows you some text-based guidance for a better balanced setup. Yeah, and compare AB. You can use that from the home screen, where you can load a session, set it as A or B. And once you have loaded two sessions, you can compare them. Yeah, so that's about it. So, I hope you got something out of this video. Let me know if you have any questions, and I will gladly answer them. And yeah, talk to you soon.